Hello and welcome to the lecture for Chapter 11. So Chapter 11 talks a little bit more about some of the disadvantages of absorption costing and then goes into a second alternative, which is activity-based costing. I think I might have mentioned this in a past lecture, but there's a couple topics in this class that I get particularly excited about. So I really wish we were face-to-face for this because I could talk 2 hours straight about activity-based costing easily. So I think it's a really, really good way to develop more accurate insights into what the cost of products or services. So this can be applied to a service-based company as well, like a hospital or a dentist office or a law office. So it's a way to more accurately determine what the costs of the products or services that we're producing really are, so we can make more intelligent decisions about which products are more profitable than others. So I'll talk about that, and then I'll talk about some of the disadvantages and advantages of activity-based costing. I've got a simpler custom example that I've created that I think will be a little bit more clear to see how this works than the examples that were in your textbook. So that will be kind of the second half of this lecture. So first, a little bit about the way in which absorption costing produces inaccurate product cost. So the big difference is that most companies produce more than one product, of course. They have different product lines, different models within those product lines, and so forth. And each of them requires different types and different levels of overhead, of support. Some products require a lot of engineering help. Maybe every product that they produce is custom in that product line, and so drawings have to be made, instructions and all of that. And so there's a lot of engineering demand for a particular product. Another product might be manufactured exclusively on a very expensive robotic machine that has a lot of depreciation associated with it because it has a high price tag. And so that product may demand more of the depreciation pool in the company than other products, and so on and so forth. So the problem with absorption costing, even if we use some departmental rates, you're still averaging those support costs over all products as if they all made the same demand on those resources. The problem with that is it gives you a certain picture of cost, which then gives you a certain picture of profitability. And that could cause you to say, wow, this product is really good. Maybe the one that's running the robotic machine. We make quite a bit of money on that. We should really promote the heck out of that and try to sell a lot more. Well, when you sell a lot more, now all of a sudden you need a second robotic machine, and there's a lot of costs associated with that. So when you use averages, you take away the insight as to the fact that some products really are costing more than others. So activity-based costing is a way to overcome that. So essentially, and I'll jump down to the thing in red, and again, it's in red because it's not in your book, but I think it's relevant. It's a way of organizing cost around activities rather than departments or products, okay? So we're going to look at all of our overhead and create pools that are associated with activities that occur in our factory. And those kind of activities might be things like inspecting products or moving products around with forklifts or doing setups of machinery, things like that. Or engineering drawings, engineering redesigns. So we'll group costs by activities, and then we'll look at what products require what activities and to what level. So we want to determine that based on cause and effect cost drivers. So what kind of activities drive costs? So the more inspections we do, the more inspectors we need, the more cost there is for that. The more complicated the products are, the longer the inspections take, the more inspection costs we have. So looking at what drives cost. So the key message there is activities like inspections and forklift driving and engineering, they consume cost. The more you do it, the more costs there are. The products that you make, and we could also say cost objects, so it could be products, it could be product lines, it could be customers, they consume those activities. They make demands on that support structure in the company. So that's a really key concept to ABC costing. So this is a graphic from your book. So we have different levels of support costs that exist. One would be the unit level. That would be direct labor and direct materials and maybe some variable overhead that's directly associated with each unit that's produced. And then we're going to have some batch level costs. So if we make 100 parts in a batch, there might be a quality control inspection on a sampling of that 100. There could be some machine setups that we have to have an engineer come out and set up the jigs in the machine properly to run that production run. Or we could have purchasing requirements. So then there are product level costs. So that's the whole product line, and that's engineering, support, documentation, all of that. And then at the highest level, there's what I would call everything that's left over, which would be factory wide. So that maybe the manager of the whole factory, the depreciation for the building, property taxes on the building, things like that. So basically, I'm going to determine these costs, and then I'm going to apply them to activities, and then apply those activities to the products. So here's an example taken from a problem in the book where they're doing that at those different levels and then applying that to DVD players that the factory makes. So I want to walk through this custom example that I've made for you, and I think this will make it enlightening. And I'll do it first. I think it'll be enlightening. I'll do it first based on what we have known up until this point, which is doing some factory-wide rates. So in this particular example, we have a toy company that makes robots and race cars. And so we estimate in the upcoming year that we're going to have $350,000 in overhead in our factory. And we've chosen direct labor hours as our activity base. So we believe we'll have 50,000 direct labor hours in our factory. And the production of robots will require 10,000 direct labor hours, and race cars will require 40,000 direct labor hours, based on what we think we're going to make of both. So I can come up with a factory-wide rate. Okay, so I have that 350,000 divide by 50,000 direct labor hours. That's $7 per direct labor hour. So we've done that before. That's a predetermined overhead rate that we'll use for applying the overhead. So let's say during the year we produced 50,000 robots and 250,000 race cars. So the robots are going to get $7 times 10,000. That's $70,000 worth of overhead. And the race cars will get $7 per direct labor times 40,000, or 280,000. So that's how we're allocating the 350, is based on direct labor hours. So when I divide that out, I can figure out factory overhead per robot, factory overhead per race car. And I'm going to assume, I just throwing this in there, that the prime cost, the direct material and direct labor, is $4 for robots and $3 for race cars. So I have a total cost using factory-wide overhead application of $5.40 for robots, $4.12 for race cars. Now, a lot of companies, and I don't think this is the right way to do it, but a lot of companies will base their pricing on their cost plus a certain margin. So if a company wanted a 25% margin, they would price their robots at $7.20, and they would price their race cars at $5.49. And they would be happy selling at those prices, believing that they're earning a 25% margin on both products. So maybe make a note of that in your notes. $7.20 for robots, $5.49 for race cars. So we would use those cost figures to judge profitability by product and make decisions about which products to promote, which to discontinue, all of that. So now let's take a look at a different way to do it. So instead of just taking one big pot of factory overhead and saying 350 spread evenly over everything based on direct labor hours, let's instead look at what kind of activities go on in our factory, and let's group our budgeted costs for the upcoming year based on those activities. So say we've got an activity called machining. So that is the depreciation on the machines, and we've got a couple of maintenance guys that keep all the machines lubricated and running, and every once in a while we have to buy spare parts and fix the machines. And the machines consume a lot of energy, so we've got those costs. So I look at that and I say that's 150 of the 350. Okay. Then I've got doing setups. So our machines are pretty complicated, so it takes the workers quite a while to set the machine up to do a different kind of production. And of course, that setup time is not direct labor. They don't have their hands right on the product. It's indirect labor, so it's part of overhead. And maybe we've got some higher priced managers that have to help with that setup. And so that cost we think will be $80,000. And then I've got moving materials around. So I've got a couple of guys that are driving forklifts. So I've got the depreciation on the forklifts or the lease expense of the forklifts. I've got propane. I've got the hourly wages of the guys that are doing the forklift driving. And so that cost, I believe, is going to be $70,000. And then I've got inspections that take place of a random sampling of these toys. And we pay our inspector $50,000 a year. So that's that. So that's my total 350, the same 350 that we used in the previous example when we talked about the predetermined overhead rate. I'm just sorting it in different ways by activity rather than leaving it all in one sum. So now I have to go and look at what the activities are going to be for all of these, for these two products. And this is the part that makes activity-based costing a little bit more expensive, because most accounting systems don't track activities, they track costs. So we'd have to have some mechanism to record the number of machine hours that are used for robots versus race cars, the number of setups that occur for both of the products, the number of movements within the factory that occur for both products, and the number of inspection hours that are incurred for both products. And so I can total that up. So I've got, you can see, a total of 30,000 machine hours, a total of 100 setups, 350 movements of product, and 4,000 hours of inspecting. It's an awful lot of hours for one inspector, I guess. So I can use that to come up with a rate for each of those activities. So for machine hours, it's 150 divided by 30,000 machine hours to give me $5 per machine hour. And then setups, that's $800 per machine hour. Moves, that's $200 per move, and $12.50 per hour of inspection. So one of the things that this will show is many times you'll do this kind of work and somebody will say, $200 to move something across the warehouse? That seems pretty ridiculous. And they'll come up with better ways to do it. Okay, like how could we make that less expensive per move, or how could I move things less, that sort of thing. And I'll come back to that in a minute. But a lot of times putting it in that kind of context brings something to light that might not have been seen otherwise. So now we can use the activities that each of the products required and the rates that we came up with to allocate the overhead in a different way. So robots here, we had 20,000 machine hours for robots times the $5 rate. So I'm going to apply $100,000 of machine hour related overhead to the robot product line. And you can see setups get 20,000, moves get 28,000, inspection hours 15,000. So that's a total of 163,000. I divide by 50,000 products. That's $3.26 per robot of overhead. I do the same thing for race cars. So I multiply the rate times the activities that the race car product will require, and I get the figures you see there, $187,000. I divide that by the number of race cars we're going to make. That's 75 cents per race car. So this process is going to more heavily burden the products that demand more activities, okay? So when I look at that, I have the prime cost that was given earlier, $4 and $3 there for, again, prime cost is direct material and direct labor. And now I've got my new factory overhead. So now I've got a more refined cost of $7.26 per robot and $3.75 for race cars. So remember when I told you to write the pricing down, the pricing we came up with for robots was $7.20. So if my actual cost, if the demand that product places on my company is really $7.26 per unit, it means I'm losing 6 cents each time I make one of those. And if I decided to promote the heck out of robots with a bunch of social media ads, I could find myself needing a whole lot more machining help and inspectors and all kinds of things that drive my costs up in an unanticipated way. So we can compare that to the costs that we got from the factory-wide. We can see it's much more uh, accurate, really, in terms of the demands that the products place on the company than the factory-wide rate is. So it's more refined. So some of the advantages and disadvantages of this, the number one disadvantage, and your book does not mention this, I should have that in red actually, is activity-based costing is not a method that's allowed under generally accepted accounting principles. So you have to have two separate costing systems, which is usually most companies judge it to be more expensive than it's worth to do that. It can be costly to identify all of these different activities and come up with activity levels and then measure them after the fact, how many setups were done each week. I mean, somebody has to do that on a clipboard, or you have to have some mechanism for estimating that. And then you can get in arguments with people about activity drivers and should I be assessed this and all of that. You're telling me to inspect the product, so why do I have to be charged for it? That sort of thing. So you can have arguments about it. The advantage is that, as I showed you with that simple two-product example, that you get a more accurate picture of what demands a product or a product line or a customer makes on the company from a cost standpoint. And so you have better information from which to make decisions about which products are profitable and which are not, and what should I do about that. So I think it really gives a lot more benefit that way. And then I think the biggest benefit is how it affects the behavior of managers within a company. So it's going to focus the manager's attention. Every manager wants their products to be more profitable. They want more money on their bottom line because that's how they're judged, maybe how they get their bonus, that sort of thing. So it causes managers to say, wait a minute, how can I reduce the demand that my products make? How can I be creative and not require forklifts driving all over the factory? Can I stage things in a different way? Can I sequence my production stations in a way that the product can flow from one product station to another without the use of a forklift? How can I do things where I don't require the activities, but I can still get my product made? Can I use testing jigs that cause the inspections to take less time? Those kind of things. So I think it helps managers look at things in a way that moves them towards making decisions that benefit the company. A lot of times those kind of activities, moving product around, setting up machines, things like that, are what we would call non-value added activities, meaning they're maybe required to produce the product, but no customer is willing to pay for them. So let's say, as an example, you were looking to buy a nice cedar picnic table for your backyard, and you were looking at two products from two different companies. And one company, for whatever legacy reason, has 5 different buildings on their site, and so they have forklifts moving material for these picnic tables back and forth between all these different factories. They have lots of forklifts, lots of forklift drivers, and a big part of an expense of the picnic table is this forklift driving. And the other factory is brand new, set up in a different way. So the forklift driver brings raw material to the factory and it just flows through the factory without any forklift drivers, and it's finished at the other end and gets put on a truck. So there's very little forklift driving cost in this other factory. So if you were buying this picnic table, would you be willing to pay more to buy one from the factory that has all the forklifts? No, that a picnic table is a picnic table to you. You don't care how they made it. You just care what it is that you're buying. So you're not willing to pay for non-value added activities. And to the extent that a costing system can incentivize managers to reduce non-value added activities, it makes the company better. So that's my ad for activity-based costing. I'm a big believer in it. The fact that it's not allowed under GAAP is certainly a constraint. I can tell you I use this method once a year. And I did it based on estimates, not actual recorded activities, those sorts of things. I did sampling and extrapolated, and I did it annually to determine true cost per product to look at our pricing. And so it was more of a project-based application as opposed to an integrated kind of application. So I hope you found that helpful. I hope the simpler example was illuminating to you and not confusing. And as always, if you have any questions, I welcome your phone calls or your emails. Thank you very much.